Welcome to the tutorial rotating objects around their center, the world center, in a fixed point in space. New developers, will-be game developers, commonly ask this question. I normally don't like the answers that are given on the forums and the news groups and the other places. One of the main problem is that those answers are really small, really short, and very quick, and they don't really help the game developer, the developer, understand what they're doing, and therefore they can't translate it. They'll have a answer that will just tell them how to rotate around their Y, the object's Y axis, or around another object's Y axis, but it doesn't translate. You just don't understand at the end of it. So what we are going to do is we're going to look at how to rotate around objects Y in space, its own Y in space. Let's see here, where is it? And then also how to translate around the center point in space, in this case around 0. Let's see here. And then we're also going to look at how to translate or rotate around another center point in space somewhere else. And not just the Y, but all the axes. And last but not least, we'll look a little bit into how this affects orbits. So in this case, I've rotated my Y axis. So when I rotate my Y, or I've rotated my X axis, which rotated both my Z and my Y axis. So when I rotate my Y axis, well, it gives me a orbital kind of rotation around that point in space, instead of the standard just rotating around the 0. So let's get going. All right, first to the project. I named mine Unity Examples. If you want to follow along, go ahead and create a new Unity project and simply name it whatever you want, follow along. If you're just looking for the math, we're going to get there quickly. We need to set up the project though. So over here in the assets area, we're going to create 2 new folders right below assets. First one called editor, next one called scripts, and then below the scripts folder we're going to create another folder called support. This is only for 3 files, so don't get nervous. In each of those folders we're going to add a single C# script. Don't worry, I'm not going to type out all the code in front of you. I'm going to give you all the code. I'm going to put all the code in the video, but I'm not going to type it out. I'm going to copy and paste. But we need to set up the project correctly. First, under the editors, under the editor folder, we need to add that C# script and name it AxisLab editor. Simple. Under the scripts folder, we're going to add a script and we're going to call it AxisLab. What do you know? And under the supports folder, we're going to add another C# script and we're going to call it Vector3 EXT, our extension. Now just click on one of them and open up your default editor. If it's MonoDev, I played with MonoDev a little bit, but I'm not really familiar with it. But I'm going to be using Unity. I'm going to be using Visual Studio 2017 Community. So I'm over on the other screen here. No, Microsoft, I did not want to make my solution window that big. You idiots. No one ever wants to make their solution window that big. And they got it. Ooh, that is so annoying. Okay, just open up each of your files. Let's start off with the AxisLab. We're going to get rid of the start and update. double click on mono behavior and change it to editor. You'll need to add the using statement for using the Unity editor. Let's go ahead and put a member variable up here at the top. Kind of old, so I used to use the m underscore because it keeps things from getting confused. So we also need to put a custom tag up at the top of the editor. And that custom tag is custom editor type of AxisLab, and that simply associates this editor with that lab. That'll work out well. Let's go ahead and jump over to the Vector3 extensions. For this, we're going to be working totally in the editor for these examples, or for this example. So we don't need start and update on any of them. For the Vector3, go ahead and get rid of the mono behavior because it is going to be a static extension class. Not going to have a lot of extensions in here, but we're going to have a few. Jump over to the AxisLab file itself, get rid of the start and the update. I'm going to do an orbit tutorial next, but for this one, we don't. Like I said, it's going to be totally in the editor, so don't worry about it. Okay, so let's go over that again real fast. In the AxisLab editor, add the Unity editor extension. Change mono behavior to editor. Associate the editor with the lab and put a stub up there for a member variable up there for the lab. In the AxisLab itself, just get rid of the start and update. In the Vector3 extensions class, change it to a static class, get rid of the mono behavior that we had on the end, and get rid of the start and update. And let's move on, get to it. Alrighty, we need to flip over. Unity was updating there. We need to flip over here, jump over to our AxisLab class, and we have some member variables to add. These variables, a lot of them will be local to the functions we're going to use them in, but we want to look and see while we're learning so we can debug it if there are any problems, and so we can also understand a little bit more fluently what's going on. Let's go through these. We have 3 Booleans. Translate, that is going to be when we grab our cube. It's going to be a Gizmo cube. It's not going to be a Unity cube. It's going to be a cube that we draw, and it's going to be when we grab, that's going to let us grab it and drag it around the scene so we can rotate in different places and see different results, reactions to the math. We have a anchor point. So translate does nothing if neither of these are selected other than hide the Unity Gizmo. We have a anchor selector and a center anchor selector. Our anchor and our center anchor are 2 Vector3s. The anchor is going to be where we're going to generate our cube. It's not that much code. The center anchor will be something we'll use in a couple next step where we'll actually rotate around that point to produce an orbit-like function. We'll get to it in this example, and then we have three vector arrays created for our axes. Now, it doesn't matter if you're creating your own mesh or if you're using one of Unity's objects, one of their primitive objects, or cube, sphere, capsule, etc. You've got to define what the axes are that you're going to use. And we're going to rotate each of those axes when we rotate the object. In Unity, when you add, come on, it's not letting me select my, window there. Okay, so in Unity, when you add a cube or a primitive object, these are all of Unity's primitives up here. You add a cube and you have it on rotate. you'll notice that there's a local and a global. That doesn't affect Unity's rotate. If it did, it would be kind of crazy actually. So when it's on global, it's showing you you're rotating it around its center wherever it's at in space. If it's on local, you're rotating wherever it's at around its center in space. We want to be able to rotate it around a point and around a center in space. We want that math ourselves. We want the angles to pass in. If you were actually using one of the Unity's primitives or a mesh your own, you would probably only rotate a single point, but you would still define the axes, the 3 axes with 2 points apiece. For our example, we're going to define 4 faces. Now true cube has 6 faces. In this case, we'll only have 4. We're not going to worry about the left and the right. And we're also going to record how far we translated each point when we get to this, how much we had to rotate each axis, and how much we want to rotate it. So what's the difference here? Well, there's a big difference. This is how much we had to rotate it to make the axis stand up in the way we originally had it. To move each axis to its zero, its neutral point, its original span, its original layout. So as we rotate them, we want the axis to, we want to know how much we've rotated it. You could record all this information forever and you would have some very large numbers and it would be very hard to manage. It's easier to just create the axes, and it doesn't hurt the memory because each axis only has 2 vectors in it. Someone may say, but for 1,000 game objects, that would be 2,000, or it would actually be what, 6,000 more vectors. That's really not a lot. When you look at the overall savings, of keeping these variables, you're either going to keep these or you're going to keep these for every object, one or the other. In some situations, you could select some points inside of your mesh object, and say these 2 points are my axes. That's a lot of trouble, and you're still saving 2 structs. You know, when you get right down to it, a vector3 is a struct just like an integer, and if you're saving, any way it goes, you're storing about the same amount of information. Vector3 is not a huge object. It got a bunch of stuff in it. It has a whole bunch of methods, but that's not the size of it. The size of it is right up here at the top. This is the size of a struct, or of the size of a vector3. Is just these guys. So it's not a huge item to save versus saving a float. You're not going to get, I mean, a float is smaller, but you're not going to get that much of a saving of a memory saving, performance gain. It's just going to hurt you in the end. So this is how much we want to rotate. This is how much it's already been rotated, or how much we have to rotate to unrotate it. And this is the size of our cube. It's going to have this width, this height, and this depth. Okay, so we're now going to add a method in here to actually create the faces. We're going to center each of our faces on the anchor. So we'll split each of our sizes by 2. Very simple faces. We're going to use Unity's Gizmo's draw line to draw them. Not that spectacular. It's not supposed to be. So each of our faces, simple explanation, is an array of 4 vectors. So it's a quad face if you were actually going to create a mesh with it. Starts on the positive at the front and it loops around. This is the front face. So this is the bottom vector on the front, top greater vector on the front, top lesser vector on the front, etc. and so forth. Here are our axes. X-axis, the anchor's X minus the width. I'm using the full width on the axes so we can see them when we draw them in the front end. And then the anchor's Y, of course, minus the height and plus the height. And same thing for the depth. That will give us something to draw so we can actually see those axes, just like whenever you're looking at Unity. Start using my other screen here to jump back and forth. We're even going to color them the same, but there they are. I mean, they'll be the same as these without the cones on top. All right, let's keep going. Next of all, let's go ahead and look at our on-draw gizmo and our draw face. Our draw face is kind of alive because we're also going to draw our axis with it. Draw face is very simple. It takes in the actual array of vectors, normally 4, maybe 2 for the axes, the color we want to draw it, and whether or not we're going to loop this array, meaning we're going to draw all the way around, or are we just going to draw to the end of the array. So if we are going to loop it, we're going to loop the entire length of the array, and if we're not, we'll loop the length of the array minus 1. Each time we go through, make a pass through our loop, we'll get the next vector. So when we do loop, we need to check if our that integer, that n2, index 2, is greater than or equal to our face length. It could be just equal to our face length, but used to putting greater than equal to. If it is greater than or equal to the face length, then we'll set the n2 to 0. That means we're going back to the start, and then we draw that line with the gizmos. And here, of course, we're showing that we're drawing each axis with the same colors as Unity does. Next part is our fabulous create function. Very simple, not really that special. Need to, on the scene view, add a using for Unity editor. You don't normally put the editor inside of a mono behavior. You could not release this code. You could not actually compile it and release it because the editor is not released with a game application or any kind of application you write in Unity. So this, we actually kill it, but we need that because if we don't, it won't refresh the updates. It won't refresh the screen to draw what we just painted, whatever we just changed. So let's so that is our editor. I'll show the code one more time in a minute, but let's jump over to, or that is the lab. Let's jump over to the editor real fast. We need to put some code in here to let us create our cube, and we're going to do that in the on inspector GUI. On Inspector GUI. This basically very basic code. I like to wrap my labels. We're not going to be using labels in here, but it's a habit. I wrap them just for convenience. We need to check if our lab is equal to null. If it is equal to null, we set it to the target. Have our button here to call our lab create method. Very simple. And then we are going to draw a default inspector. But we also need to set our lab equal to our target in the on enable, because we're going to be calling it in a few minutes or in a few seconds in our on scene GUI. But before we do that, we need to bring in 2 more methods to edit those anchor points. So these are this is where we edit, where we move around our 2 anchors. Unity specific. The matrix is not needed for this specific project because we're drawing with the gizmos and we're not manipulating those frames when we manipulate the world. When we rotate everything, screen recorder won't let me select. I have to go over to my other monitor to actually select something. So add an AxisLab. So whenever we're over here and we create, there's our cube. If we rotate this, it rotates our axis, our standard Unity axis here, but it doesn't actually rotate our cube. So that matrix is really not needed in this particular project, but it will be needed later on. And some people have a problem with it, so I went ahead and put it in here to kind of give a sub-tutorial. We're going to multiply the point, the anchor, whichever one we pass in. This will state how that anchor, that handle on the front end is going to point. Whatever we're saying, whatever the current identity, the current neutral is. If we move it, if we move that anchor any, then we need to once again use our matrix to unmultiply our point. Set our point, which we've passed as a reference. It's a struct, so we must pass it as a reference to those return values. And if we pass in true on the create, then we're going to call lab create. And also just some standard code here. If we didn't change, if the GUI didn't change, then we'll return false or we'll return true. Now, last part of this code in the front, in the editor, like I said, it's going to be simple. On scene GUI. Very simple. If the anch variable is selected, not very creative, then we'll be editing the anchor. We'll show the handle for it. And if the center variable or the send variable is selected, then we'll edit the center anchor. So let's look at this and see what happens. See if I got everything in there. So first of all, we click the translate, and you notice that Unity's GUI or Unity's handle disappears. There it is again. That's actually our anchor because I've selected the anchor. I was told that I need to use these pins more often. So there we go. I'm not very good with the pins. And we can also reset our anchors right here. Go away, eraser. So I'm just going to drag our anchor around. There we go. It doesn't rotate yet. And I can also show our center point. There it is. But we're not rotating yet, so it doesn't really matter. We'll get to it though in just a few minutes. Let's keep this going. Next step is the math. Let's get to it. All right, time for the math. Please don't run. We're going to be working with plane rotations. That means we're going to rotate things on a plane. We're not going to rotate them carry. We're going to rotate them directly on a plane, which is pretty standard. We're going to rotate our X, our Y, and our Z along the X, Y, and Z planes. That means we have got to straighten the other two variables of each rotation back to where our axis is as it was in its neutral form. It may not sound like a lot of work, but when you see a method that doesn't do this, just click in your brain that it does do this. It has to do this. Or it's not rotating locally, it's rotating globally to whatever manipulation that object already is. Somewhere along the line, though, those axes are saved and are being rotated with the object and being unrotated whenever you want to continue along your rotation. So let's get on with it. So we're working with left-handed in Unity, and that's very important to understand because the left-handed coordinate system, as it is, has a different quirk than the right-handed coordinate system. Well, you know, the left-handed coordinate system, which both Unity and Unreal uses, the Z is a little quirky compared to the Z angle is a little quirky compared to the X angle and the Y angle. And I'll show you what I mean in a minute. Now, I know some of you who have played around with Unreal are immediately thinking, no, I've played with Unreal. I know the axes go in different directions than in Unity. You're correct, but that's really nothing. It still uses the left-hand coordinate system. Just the way it is. Now, the angle method we're using is a method for 2D. We're getting the arc tangent with 2 inputs. If you ever notice arctan has either 1 input or 2 inputs, that's what it's talking about. And you may have to do an include here to use the system, because I'm not using Unity's MathF. I'm using Microsoft's Math, so this code is portable to other Microsoft projects or other projects using .NET. If I use MathF, which is Unity, then it would only be ported. It's only available to other Unity projects. We're also using an extension here, meaning that when you type in a vector, bam, you see our angles. You'll see all of them when we add all of them. And you'll also notice that you only see the one value from the extension method. That's because we're including the other value right here. That's what this does for you. If you're not familiar with extensions, they have to be in a static class and they have to be static. So we have 2 different methods of our Z angle here. One is reverse of the other one. This one is the reverse one. We will only use this in Unity in the left-handed coordinate system, oddly enough. Now, the reason being is angles and directions and normals, in a strange way, are only a matter of perspective. They're not. They don't exist. They're not there. They exist in math, though, and they exist in math in the way we define them. And because of that, all of the different handed coordinate systems, and there's also a top-down system, which is also a method of computer software, but there used to be a top-down system a long time ago, back in the early DOS days. They each have a quirky variable. For the left-handed, it's Z for us. You may not notice it in other areas, but you will notice it when you're doing rotations. So this retrieves our Z angle. And our Z angle inverse, you might as well call it inverse. It's using an inverse method to get it, should I say. Not necessarily the inverse amount. We'll take a look at that. So let's go ahead and get these other 2 in here. And for all 3 of them, we're using the same method. And this method is really developed only for the 2D plane, which is considered the X plane going up and down. So the X plane goes up and down. The Z plane goes forward to backwards. The Y plane actually goes flat. If we go back to Unity, you can see it on the axis. There's the Y plane going up, and the X and the Z plane look flat. But in all actual fact, this plane is a plane. Bam, there's the Y plane for our purposes. And then this would be the X plane. And if we rotate it by 90, there's the Z plane. That's pretty much it. Planes simplify things. They're going to simplify our work. Let's keep going here. Let's see. I am not missing one because I've done those 2 summaries. Okay. We also need to bring in these 2 methods. ToDegrees and ToRadians. We are passing everything around. We will be passing everything around in degrees. This makes it easier for our human eyes and human brains to understand. A radian is almost always a decimal value, a dot value. I mean, there's a very small chance that it won't be. So these return their value in radian, not in degrees. So we can debug. We're going to use this, and then in our actual rotate methods, which the Z is quirky in them also, or is different than the other two. Also, you will notice that the first thing I do is convert our degree to a radian. It's mainly for this tutorial. Now these methods, this information, if you notice, these are member variables. These are not local variables. These come from my own matrix code. It's not that big of a deal, but I simply brought it into this project, summed it down to something that's more usable. You don't really have to create a matrix, your own matrix code to work with this stuff. Just for fun for me. But these are the, I'm not going to go a lot into matrices, but these are the standard matrix values from the matrix grid. And we multiply and divide them, or multiply them and add them, subtract them sometimes to get different rotations, different translations, different scales. Notice that on our X and our Y, we add on both of them and we subtract on this first one. The negative of this value plus that. Yes, there's an easier way to do it. But when we get down to the Z, we don't do that. And we subtract the first one. It's a little different. The reason being is that we're in the left-handed coordinate system. I think it's too much to go into in this tutorial though. Now we actually have to read up to remember it all. So those are our rotates. To rotate everything along a plane. Let's put our translates in here. And then we only have 3 more math functions to go, and we're not doing them today. Or we're not doing them right now. We are going to do them today before the end of this tutorial. Translate's very simple. Add the vector, how far you want to translate along the X, Y, and Z to the current vectors. That's translate. Very simple. Now let's jump over back to our AxisLab. And let's put our methods in here to rotate around the 0 point, the vector 0. First of all, we have our prepare function. Now the only reason this prepare function is separate from the actual rotate function is so we can see the result. We want to be able to call this separately in our editor and see what it does to our cube. If you notice, our Z-ang is, as I noted, I believe I noted before, we actually have to manipulate it, the result of the inverse. But the XY value does not return the proper value. And we rotate our x-axis, because that's the one we've got to straighten, and then we rotate our y and our z-axis by the same amount, and we rotate all of our faces by the same amount. Why are we doing this? We are unrotating, unwrapping what we've already wrapped in our rotation. And since we haven't done any rotations now, that's not that big of a deal, but we'll in a little bit. Now, when we revert, after we do the rotation, we're simply taking those stored values and rotating in the opposite direction. And now if you notice, for the x-axis, I get the z first, then the y. And then I rotate the z first, then the y. Z first, y. When I unrotate, I've got to do that in the opposite order with a negative value of what I rotated with. So it's y, then the z. Very simple. And then just for proficiency, I reset all my values, all my variables. Okay, and now the very simple X rotate. Very simple right now. We call the prepare to unwrap our axis. We rotate whatever we're going to rotate the x-axis, then we revert and undo whatever we done in the prepare. And this will give us something that's not very special right now, but will be shortly. Okay, so not really a Unity class, but let's go ahead and separate these up. Each of our buttons into the X, Y, and Z category. So this, I guess, should be prepare for X. Undo what you did. And there we go. Very simple. Now you don't have to compile with Unity, but I do. It's a habit. Select and make sure you update it. And now if we prepare right now, it's no big deal because we don't have anything to prepare for. But if you notice where our X is, where our cube is located, it's rotating around the X. Let's get rid of that skybox right now. So if we put our anchor back to 0, create there, our Y, our Z, and of course our X. I'm in ISO view, and I rotate, and if I prepare, it's not going to do anything because the X and the Y and the Z aren't really affected yet until we actually rotate our Y and our Z. So we'll see this working a little bit more, these two working a little bit more in a minute. Remember though that the rotate actually calls these two. These are just for us to debug. If we click on that beforehand and then rotate, you can get an unexpected result. Let's jump back over to our code. Rotate, revert, prepare, and let's just bring these other two in here. X or Z and Y. Now if you notice also, I'm calling scene view repaint on each of these, and that's so our gizmo, that's so this is called. If we don't call this, then we won't see an update in our screen. These are exactly the same, except they're for different axes. Prepare Y is going to check the Z and the X axis, and then prepare Z is going to check the X and the Y axis. It's just that simple. And we're just going to grab that, copy in there twice. Let's see here if I can just X with the Y, and then X with the Z. X with the Z. To Unity updates, there they are. Alright, so let's rotate our X first, then let's rotate our Y, and bam, we are rotating on our Y axis. This is not the global Y axis, of course. And our Unity is now hiding this arrow, which can be a little bit haphazard later. So let's see what goes on here. Let me go ahead and rotate the Z also. Now if I go up here to prepare for X, bam, it rotated the Y and the Z to straighten them. So I'm looking down the Z right now, and I'm looking down the Y, and the light's in the way. Go back to ISO view. It's actually pretty good. It's not perfect, but it doesn't matter. It doesn't need to be. So there's the Z axis, and the reason it's not perfect is the X axis is still rotated. That's what we want. We want to know how much we want this, everything else is changed to change back so we can rotate the X. And that's what prepare and revert does. So whenever I revert, we're back to our rotation point. And that is this section. Next we're going to orbits. Before I go to orbit, let's go ahead and do a translate here. So right now we're orbiting around the 0 point always. So if I rotate the Z, well, that's fine. I'll put the Z over here. There we go. So we're rotating around the Z of 0. And we want to be able to do that into any point in space. And that's only a few more lines of code, I promise. And then now we're rotating around the Y in space. So if we look down here, so now we're rotating around the 0Y. Whatever, if we create, put it right there, and now we do the Y from where we're at, we don't get that orbit. Well, we get an orbit, we don't get that eccentric orbit. So let's go back to create. Now if I rotate my X just a little bit, and now I rotate my Y, I get a more orbit, more like a planet or a satellite or whatever. Whatever you're trying to rotate in space. Alrighty. That's it for this section. It'll be just a little bit more. I know some people hate math, and I try to help them get through it. Maybe I should just tell them to buck up. But the math, this is math centric. I hope it helps you understand it a little bit more. See you in just a few seconds. Okay, so let's start off by actually having our point rotate around its center, where it's at. Right now we are in orbit mode, but orbit mode is next, so we'll finish it in next, I don't know, 10, 15 minutes. But right now we are rotating on orbit around 0. That's not what we want. When you click one of these, it should rotate around its center, right in that spot. Just a few lines of code. First of all, we're going to jump back over to our vector. We have one method to add. Now, it's a midpoint method. There are reasons for the other 3 versions of midpoint. I'm going to include them, but we're not going to use them. Midpoint XZ gives you the midpoint between 2 vector3s along the X and Z axis, ignoring the Y axis. Midpoint XY gives you the midpoint along the X and the Y axes, ignoring the Z axis. And midpoint YZ gives you the midpoint along the Y and the Z axis, ignoring the X axis. Midpoint is simply the halfway point in between 2 points, and the math is this simple. Add the Z's, divide by 2. Add the Y's, divide by 2. Add the X's, divide by 2. It gives you a point along the normal between 2 points. We need this because we need the center of our axis. Now we could, I guess, save the center of our axis also. I don't want to. It's a little bit of overkill. Okay, so let's jump up to our prepare X. That's the first place we're going to do something here. We've got to add a translate before our rotates. For everything, we have to translate this point back to 0 space. Pretty easy. Sorry if I'm scrolling too fast. So I get the midpoint of between my x-axis 0 and 1. I'm going to translate that far because that's how far it is from 0. I have to translate all my faces that distance also. If you're working with a predefined object, it's still that simple. You're simply going to translate it that far. Now jump down to the revert X. And we're just going to untranslate it back to where it was. And my neighbor's dog's barking. Okay, so now let's jump over and just look at the X rotation. If we rotate our X now, it's just rotating right there. Boom, doesn't matter where we're at, wherever we generate it at. That is like how Unity does it. But now, let's go ahead and get our other 2 done. And then we're going to add the methods. to rotate around an orbit. And then we gotta do prepare Z. Exact same code. This could be broken off in its own function also. If you really want to go with that simple method, which I like, break them all off into their own little functions. Okay, so now our Z, scroll in a little bit so we can see it. Now our Z is rotating around the Z. The blue line is the Z. And rotate our Y. Rotating around our green line. Now if we, whoa, see what's happening here. When we prepare for our rotation, notice that it goes back to the 0 world. Now if we revert our Y, actually if we revert any of them I believe, we're back over to where it was. So now, boom, we should be good. Okay, so let's rotate our X, rotate our Y, prepare Y, revert Y. So prepare for the Z, revert for the Z, right back to where it was, how it was. And that's why we do our angles in the way we done our angles. When we revert, we do everything in the opposite order in which we originally did it. All right, so we have one more or three more methods, one more thing to really accomplish the full scope of this idea, of this tutorial. And that is rotating around a point in space, a center point in space. And that center point I named center point, center anchor. Wow. And we'll start off with the X. Unlike our other method though, we're not going to split these up. They're all jumbled together into one method. So notice the difference between our rotate X. We move on our prepare X for our standard, for our rotate X around its center, we move it by the midpoint. As I said, you don't really have to move and translate. You can work all this into your rotation calculation. So you would simply move it into here. Maybe I'll work something up, an example of that another time. But you should be able to figure that one out, I hope. If not, I'm sorry. So we, in the case of our rotate around a point, a center point in space though, we only move it the distance that the center point is from 0. Pretty cool, I think. So if GUI layout.button rotate X center, center anchor, mlab.rotate X center, and now we do need to see where exactly did we leave our center point. It's over, it's at 0, 0. So everything here should be pretty much the same. Let's look at our X. And since our X was a little bit rotated, it's not going in a perfect orbit. It's going all the way around there. So let's do that. Reset everything and bam. Now if we move our X, little bitty orbit because it's right next to it. And if we move our X way over here, or our anchor, excuse me, our anchor, it's a huge orbit. Now if we create, and now let's rotate our Y and rotate our Z, and now we get a eccentric orbit, or normal orbit, what I would call normal orbit. You never see a perfect orbit of planets when you're watching the different documentaries and stuff. But that's pretty much it. The only difference between our rotate around our anchor and the rotate around 0 is how far we move it. For this, we move it by the distance of our midpoint to get our midpoint back to 0. For this, we move it the distance of what we want to rotate it around, getting that point back to 0. And in the same way, well, we're not moving the midpoint in this case. We just leave it where it's at. We don't care about it. But when we get to the bottom, we reverse everything. We move it back. Let me go ahead and put these other 2 methods in here. And I will get them posted and put a link at the bottom of this video on YouTube. Let's look at them. As I said, the only difference is we just move based on the center anchor. Wherever it's at. We're calling create on that. Let's not call create, and we can show a little bit of disruption because we've moved it to a point in space. We've moved our cube to a point in space based on a point in space. But if we don't recreate our cube, it does act a little bit different. So let's create. Okay, we just create it. Rotate our X normal first. Rotate our Y. Rotate even our Z. And now, see, I'm getting my rotation because I'm kind of going this way because I've rotated it that much. Now I'm gonna put my point way over here. Well, I've moved what I'm orbiting, so my orbit gets kind of wild. It does change it a little bit, is all I'm saying. Let's jump back over to our editor. Put our other 2 Z, Y. And update Unity. Recreate. Let's move our point in a little bit. Rotate our Z around our anchor real small. Rotate our Z around our anchor here. Wham! Huge. Now if we move it again back to where it was, well, that made it even bigger because of how far it was away from where it is now. I hope that makes sense. All right, thank you very much for watching. I hope this taught you. I hope you understand angles and rotating objects around their center point, around a point in space, and around 0. I hope you learned a little bit more about degrees and radians. Like I said, I'm gonna post all this to Pastebin. And once I get that posted, I will put a link on YouTube at the bottom or at the top of the page right below the video so you can go and download it. God bless and thank you.